Have you ever thought you got good astrophotography data, or actually maybe you did really get good astrophotography data, but instead you end up with this? Well, after 2 years of hard work on astrophotography skills, I actually came up with this. Let's take a look at how I actually came up with this image. Well, first of all, I didn't use Photoshop. I used PixInsight. Photoshop, well, to be quite honest, it's not really meant for astrophotography. So unfortunately, if you already have Photoshop, well, I'm not going to be using it in this video because PixInsight is actually the real way to go if you want to get serious about this hobby. Yes, Photoshop can definitely do some hard work, but PixInsight is technically the way to go if you want really excellent, detailed. If you're a pixel peeper like I am, then you want those excellent fine details in there. So you want to go with PixInsight in that case. So let's go and open up our image of, I think it was M31. Yep, final M31. My file system is a mess, but that's just me. So, in order to get this image started, actually, I think I screwed up the data more so in the first one than it already was to begin with. So, that was like 2 years ago. In order to process this image, the first thing we need to do is I can clearly see there's kind of like a huge vignette around this image, but before I do that, I'm actually going to do a slight dynamic crop to get rid of as much of that deep sky stacker effect as possible, because if you go way up here, you see those little lines. Those are deep sky stackers effects. So, I'm going to do a slight dynamic crop, but I'm not going to crop it as far down as I did with the other image, because if I do, what's going to happen is it's going to get really noisy because this image is huge, and so you don't want it to get that noisy. Because the more you zoom, you see the noise becomes bigger, and it's more distracting when you zoom in. So if you took an image wide field, I would keep it wide field. I wouldn't zoom it all the way, and that's a bad habit I used to have. So what we're going to do now is I'm going to hold Control while I go to do dynamic crop. That way I preserve my aspect ratio and don't change the weirdness of the image. Or make it weird anyway. Oops, what did I do there? Reset, and I'm going to do a crop. Control, hold it down. We're not going to crop it that much. We're just going to crop it a little bit. I don't want it center. Doesn't really matter to me because I want to remember we want to preserve the noise in it, make it small as possible. I think that's good, but I will rotate it 180 degrees, like so, and click check. And there we go. There's our image. It's way out to the side, and that's why centering in the frame is very important. When I was new to this, I didn't really know how to center because I didn't really know exactly how to use the star patterns to center my images because I'm in a Bortle 8 sky. Let's go ahead and close out a dynamic crop, and yes, we're going to cancel because we already cropped. We're going to zoom to fit it now, which actually zoom to opposite fit. That's too big. The next thing that needs done in the image, obviously, is a dynamic background extraction. In order to do that, we'll go to Process, All Process, Dynamic Background Extraction. And I wouldn't use Automatic Background Extractor because it's not very good. Especially if you have more gradients than you need to. So if you use flat frames, and for example my gradient got severe when I used a flat frame, what I would definitely do is not use automatic background extractor because that is a very bad prediction because it's doing it for you and it just doesn't really know where the stars are or whatever. So you got to tell it because humans are more precise than the computer is at the moment. Okay, let's go to dynamic background extraction. So the first thing we're going to do is we're going to reset it to make sure everything's centered and this image is selected. And then we're going to go to Target Image Correction and select Division. But before we do anything, we are going to go to Sample Generation, change the default sample radius up to 50. The reason why I'm changing it up to 50 is because I want the largest amount of section that we analyze to be in the view. So that's what we're going to do. Samples per row, I'm just going to set to 6. It's too much work if I go around the whole image. And it's a lot more work, actually, maybe 7. That's only 1 of 9 samples. Let's actually do 10, and so forth. So you just go through each of these samples, and you get rid of the stars, so that way it doesn't subtract the stars as well, or get that messed up for gradient, so that's what you don't want. So I'm going to see you guys when I finish this up, and I guess I'll see you in a minute. Just finished dynamic background extraction. So what I also did is add a symmetry around the edge of the image, the circle. because it was a huge halo in the middle of the image when I did the dynamic background extraction. And I'll show you in a second. It's not the best. You'll see. Because this image has a lot of vignetting, it's pretty hard to do, but, and plus this is a video, I don't want to make it too long. And here's what I got. So it's not the best, there's some dark spots over in the corners. But what I can do is do I'll process dynamic crop again, but I don't want to crop it too far. And that's not too bad. Let's go ahead and take this down a little, so we can center both galaxies. And there we go. Let's zoom it to fit. And there we go. Alright, now, as you can see, we need to remove the dust spots for sure. Background looks alright. Doesn't look too bad. Nothing to really nitpick except for up here, this little area, whatever. But I don't want to make this too long for video's sake, as I said. Let's go to process. I'll process something called clone stamp, which I believe is right here. Let's turn up the radius. The radius is basically how big you're going to clone. 50. So, we're going to hit Control and select a sample, like probably like over here. Actually, I might need bigger. Let's change it up to 200. Yeah, that's great. Okay, so we're going to select the sample like 200, and then we're going to go in our point where we want to sample it and tab. And there we go. Perfect. We just dab there, and it's done. We don't even have to mess with it. Actually, I might mess with this up here, though. It looks a little dark, but we might want to turn it down to like 150. Good way to remove dust spots, but in not letting people know you just faked the stars. But that's what I do sometimes with my images, just because there's dust spots and I don't want to deal with removing them, especially for video's sake here. That one looks stupid, though. And then when you're done, make sure to click the execute button, or else if you close out, it won't be saved. Okay, there we go. So our image looks a lot better. There is a little darker shades of whatever, but who cares, because this is just a really far stretch, and we're not going to stretch it this far anyway, and plus this is a video, as I said like 300 million times. Alright, so now the next step, I would say the next step would be to do some deconvolution with Blur Exterminator. Now, I bought this software a while back. It's pretty good. Really good, actually. I did a review on it on my channel. If you want to go check that out, you can. But here's Blur Exterminator. I'm going to sharpen the stars. Since this is a relatively big star image, I'm going to sharpen it just a little higher, 0.37. In terms of the sharpen non-stellar, I want to keep that down because this is again going to get pretty noisy, so we're going to go 0.90 as the default. And I don't think we have really any star halos in here to deal with, so we're going to apply. Or we could just drag this triangle, same thing. Or that's just the triangle is an instance, and then the square is to apply. Guys, it officially finished. So here is Blur Exterminator's result. We can see that the stars are nice and small. If we go back and undo that, as you see, they're huge and have like a color effect around them. If we go here, they don't have any color effect, and they have a nice small effect, or size. So there, it's really nice and small. And the noise, let's see if it's affected. No, the noise was actually not affected. Cool. Okay, cool. It wasn't sharpened noise. Cool. Alright, now the next step, as you can see, Andromeda looks pretty good. The next step, I would say to do, there's not really much wrong with it. I mean, actually, it looks pretty decent. I would just say maybe do a color calibration. I would say that's the next thing. But before we do any of that, I would definitely stretch the image. Because it won't color calibrate correctly until we stretch the image for real. Because this is just a preview. Let me close out RC Astro Blur Exterminator. And we're going to turn off the stretch right here. And then we're going to go to Process, All Processes, Histogram Transformation. We're going to go to Final M31 DBE, which is the dynamic background. We can actually close out the background here. Let's go ahead and turn this up. We don't want to stretch it too quickly. Okay, that looks much better. You can even maybe see a faint bit of detail on here. Okay, let's go ahead and close that histogram transformation now. That looks actually pretty decent. Let's go ahead and go to Process, All Processes, and we'll go to Color Calibration. Everything looks good. I don't really mess with this, and I just let it do its stuff. That looks more natural. Well, actually, wait, this looked natural, but I think this looks better. Let's compare the star. Stars maybe are a little bit more blue rather than white. But I think that's alright, because some stars are actually the color blue, because if you look down here, they're all different colors. So I actually think that's pretty good. Let's go ahead and go to background neutralization. I also like to use that, just to get the background kind of dimmer out. Let's compare. Not much of a difference, very subtle, but you can see kind of help the background. a little bit more neutralized, maybe natural. Let's go ahead and go to process, all processes finally, and we're going to go to curves transformation. In order to do saturation, we're going to select the saturation tab over here, and then we're going to pull this up just a slight bit, and we're going to do live preview, which is that button right there. Oh yeah, let's view that. Oh, that looks pretty good. Turn to saturation. Don't want too much. Oops, what am I doing? Oh, maybe about right there. That looks good. Let's go ahead and do that. There doesn't look like there's much color noise, which is good. And as you see, well, there is a little color noise, but we have more detail in the galaxy. The only thing I would say left to do is to maybe dim out the core just a little bit. So we're going to go to curves transformation, close that out. We're now going to subtract the luminance layer right here. I learned this from Chuck's Astrophotography, the HDR multi-scale transform thing, how to kind of dim things out and make them smaller. Let's see. I'm going to drag this over here, this little icon, to put an instance of a mask over here. Get mask, turn off the mask so we can actually see what we're doing. But we're not disabling it, we're just showing off turning off the preview. Now we're going to go to HDR, multi-scale transform. And that is where I never can find it. It's right here. It's in front of my face. Okay. So now we're gonna do number of layers. I usually like to do 5 because that helps really dim it out. Let's go ahead and do apply. And this might take a second. I'm not sure how long. Oh, that was quick. That might be a tad too much, as you see, because it kind of really dimmed it out, and it kind of turned blue. So we want to actually maybe change it back to 6 layers. Do that again. As you see, that looks perfect. Before, after. As you see, there's much more contrast in the Spiral Army. You can actually see more of it. Let's zoom out and do it before and after. Before, oops, is it? No. Before, after. Yeah, much, much, much better. Now, actually, I might do a little bit of denoising, just because I think it needs it. So, what I would do, is that mask still on? Let's see. Yes, but I feel like I need to brighten up this mask. So let's go and brighten up the mask, reset it, and we'll do the clone, or the luminance, whatever. We'll brighten that up just to show more of the galaxy, and then we're going to turn down the black point. And this is just for demonstration purposes, or for masks purposes, so we don't necessarily need to make it perfect, because we're only doing this for a mask. Just to make the brightness come out. Okay, I think that's good. Let's close out of this. Mask, show mask. That's better. You can see more of the galaxy, not redded out. That way we preserve the galaxy and don't denoise that as much as we denoise the rest of the image. So we're going to use ACD and R. I usually use multi-scale linear transform, but for the purposes of this short tutorial, or supposedly short tutorial, we'll see when I edit this, that it turns out pretty good. As you can see, the stars look small. You have less noisy background. There's the galaxy. Not bad. You can see some details in it. This is a really old image. I don't even know how. It's been like years since I took this thing. So if I go ahead and compare it, I think that's all we're going to do today. So if I compare it to my other image of Andromeda, as you can see, that's a huge difference. And this is the same exact image. That is a massive, 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 massive difference. As you can see, the background is very clipped. The stars have like halos around them. This was with my Rokinon lens, by the way. Rokinon 135 f2, if you're wondering, and then a Canon T7 camera. As you can see, it's very noisy. Here it's not. As you can see, the stars look a heck of a lot better here. You can even see the tiny details here, which you can barely see them there. They're all blurred over. I mean, they're both blurred over, but this one's a lot worse in terms of noise. If we zoom out to about the same scale, should be about right here. Oh my gosh, yeah, the color, everything looks so much better. And this one, yeah, the background just blends in better here. Yeah, much, much, much better. Too much noise here. It's less stretched here, but the difference, yeah, look at the core. The core even looks better, but the difference is it's too stretched on this one right here. You can see all the noise we have, and I clipped the background. That was terrible. So yeah, that is a lot better. All right, maybe you can even see the dust around. I'm not really sure. Let's zoom out. And that's why That's why I said in the beginning, I wanted it to be more of a zoomed out image, since we had that field of view. Zoomed out looks a lot better than when you zoom it in like this. That looks more blurry, so if you were to crop it in like this, it would look terrible. It would make you look like a beginner, whereas if you keep this out here, it makes you look more of a professional. So, not to say I'm a professional, I'm definitely not at all, but I'm saying if you want to make your images look more professional, I would definitely say maybe make them zoomed out, because that, like your original field of view, close as possible to your original field of view, not just a cropping on the eyepiece target. Make it look more like a story you're trying to tell, or a masterpiece, but not necessarily like all the way zoomed in, because that'll make it look terrible. How long have you been doing astrophotography for? Let me know down in the comments below. Anyways, until next time, clear skies.